For the given circuit, we want to find Norton's equivalent for terminal A and B here. So what I will do, I will first redraw the circuit. I will replace 4 ohms which is connected between terminal A and B by a short circuit. So this is there, and then this is the 6 amps current source, and then 2 ohms resistance here, 3 ohms, 6 ohms, and 120 volts. So what now I will do, I will convert this voltage source and series resistance into a current source and a parallel resistance, and I will convert this one. So basically what I'm trying to get is, I'm trying to get if I can get a simple series circuit by making all these conversions. So let's see where we get there, so whether we get there. So this one, let's just convert this one, so it becomes a current source, a parallel resistance, the value of the resistance is same here, and then 3 ohms there, this one is there, and then here resistance and a voltage source. That resistance is 2 ohms. This current, so the value of the current source will be 120 divided by 6, that is 20 amps. So that's there, and the value of the voltage source here will be 6 times 2, that's 12 volts. So we have them. Now these two can be, so this is terminal A and B, we cannot change that, that is there, and this is the current we are interested in. So 3 and 6, these two are in parallel. If I can replace them with one resistance, that will be 6 times 3 over 6 plus 3, the parallel combination, which is 2. So I have 2 ohms there, and then 20 amps there, and here 2, and here 12 volts, and that's 2 ohms there, and this is terminal A and B there. So now what I can do, I can reconvert this one into a voltage source and a series resistance, and then I will end up having one series circuit. So I will do that. So this is 40 volts, and that's the resistance, which is 2 ohms, and then my terminal A and terminal B here, and then again 2 ohms, and this one is 12 volts there. That's it. So now I am interested in this current, which will be my I short circuit current here, or I Norton current, whatever, same thing. So the value of the current will be, of course, these two voltage sources are opposing each other, but this one is higher, so the direction of the current will be here, this way. So IN, as I have drawn it there, will be positive. Value will be 40 minus 12, that's the resultant electromotive force, resultant voltage source, divided by sum of the resistances. There are just two resistances, 2 plus 2, 4, so that's there, so that will be 28 over 4, so 7 amps. That is the value of the Norton current for terminal A and B. So that's we have found. Now we need to find the Norton's resistance, which is the open circuit, which is the resistance seen from here. So I will work with this circuit, because this circuit is essentially the same, and we have seen in previous examples that we will get the same result, we know. So I will just work from this circuit, and I will erase this part now. This is the resistance that I want to see, as seen from here, the value of the resistance, which will be R equivalent, R Norton, let's say, and the sources will be inactive. In this case we have two voltage sources, both will be inactive, so both will be short circuited. So these two sources will be short circuited. I'm just erasing this part instead of redrawing, and this one will be short circuited. So basically what we have now is 2 and 2, they are in series. When the resultant resistance seen from here, these two and these two are coming in series, and that's the value of the resistance. So Rn will be 4 ohms. So we have the equivalent Norton circuit for this, which is 7 amps Norton current, and resistance is 4 ohms, and this is terminal A and terminal B. So whole of the remaining part of the circuit is replaced by Norton's equivalent circuit, the value of which are these current and resistance.